I saw it earlier was a Rizzi, and this is my plant project. So I've got it running and the graph is showing the moisture values. Right now it's in wet soil. So pump is off, soil is wet because I've already watered it a bit. So if I move it to a more dry area, if it's in the air, it's obviously drier, so I don't water it. Now if I put it over here, it's still wet. But we'll see when I take it out. It is moist because I still have it like slightly inside. And right now it's over watering it. But this happened because I didn't have the moisture sensor near the pump, so I wasn't reading the values right by the water. So for CLO2, I am using the Fermata imports and the STD draw. I've initialized my board with the Fermata and my Studio Draw to draw the graphs all over here. And it refreshes the page after 30 samples. For CLO3, it stores the array list. So I have an array list and it gathers data from getting the moisture values from another class, and it adds it to on from this variable. I just add that variable to here because it stores doubles. In my run method, this is where I show if I need more water to be pumped. So if it's dry, I pump it for 2 seconds. If it's just wet, watered, or moist, pump it for 1 second. And if it's else, which means it's wet, then it'll not pump anything. And here's all the prompts on all the OLED screen that you'll see, as well as a sample moisture value, which I get just from getting the value from my moisture, which I initialized in my task class over here. My moisture from the pin of the moisture pin, pin number 15. Pin number 15 from A0, and the pump is 2. I use object-oriented programming in this by bringing in objects such as the board from the first class and the OLED object. So I do that when I create my new task. I'm giving my board object that I created from here and my OLED object that I created from here. And this way I can create constructors to make changes and to do things with them, such as turning them on or off. And that's the end of this plant project presentation.